Hey guys, I thought I'd give you a third and final update for the filament dryer. It is now complete and I should be posting it in the next couple days here. I got a write-up for it. I made some updates to it to improve things and fix some of the problems that were with it. I thought I'd go through that and just kind of explain what's going on. So if you decide to build one of these, you know why I did it. So if you remember, if you leave the filament in there too long at a high enough temperature, you would get that happening to your spools. And this did a number on the PETG too. So I was trying to figure out what was going on. So number one, what was going on was that originally on the reader here, the temperature and humidity sensor was on the back side. So that's in the middle of the bucket. As most of you probably know, hot air rises, of course. So it is hotter towards the top. So my first thought was, well, let's move the temperature sensor up towards the top where the max temperature is going to be. We want to measure the max temperature, make sure that it never exceeds that temperature. But that was only part of the issue. The other issue was a different type of heat transfer. You got conduction, where you touch something and heat transfers. Convection, where you basically are transferring heat through a moving mass, which usually is like air. Right? So if you, I'll put a picture up here that kind of explains that if you're confused about that. Here you have the three types of heat transfer. Conduction, where heat transfers through a solid object that you're physically in contact with. Convection, where a fluid such as air moves heat energy to another location. And radiation, where you have heat energy that is radiated to another body. Third type of heat transfer is radiation, and that's not using any mass. It's just light energy being emitted and absorbed by whatever it's touching. And you happen to know probably that if you wear black on a sunny day, you get hot because it absorbs light really well. So what was happening was the light emitted by the light bulb was bouncing off the foil on the inside, which is good. And was reflecting back, and this side that was melting was towards the inside, so it bounced off and hit the top and started absorbing the heat. And if the light would stay on too long, it would over time get hotter than we'd want it to. Some radiation was good, because if you didn't have the foil in the bucket, the radiation would hit the side of the bucket, heat up the edge, the outside of the bucket here, and transfer out of the bucket. We want to keep the energy on the inside. So having the foil in there was good, keeping it in there. We want that energy to stay in there, but we just don't want it to be absorbed by the roll. First thing we did was we needed to block the radiation from hitting the roll and heating it up too much. So what I did was designed this ring here that is siliconed onto this piece of foil. So you will find that it's strangely slightly larger than the diameter of the spool. So now when we're drying out filament, you put this roll in the bucket on the hook and put this on the outside, which keeps the radiation from hitting the roll and causing your filament spools to start warping. The second thing we did was we moved the temperature humidity sensor from the inside down here. You see it right there, down there in the middle, to a wire that we can place anywhere we want to. And what's nice about this is I designed in a clip on the outside that should fit most plastic rolls. Just in case it doesn't, I put a 3mm slot up here, so if you have 1.75 or 3mm filament, you can use a piece of filament, wrap it over the top to hold this in place. But if you have, say, a Matter Hackers roll, or I tried it on Village Plastics, Lulzbot, it works pretty well. So you can go in here, press it on there like that. It'll sit right there. And if you need to, you can take some filament, place it over the top like that, and hold it in place. So the nice thing here is that now I'm measuring the temperature at the top of the roll near the top of the bucket where it is the hottest. And it's close to the plastic, so even if you didn't have the shield, it should get a more accurate temperature reading of what's in the bucket. I found, however, with the radiation shield in there, that we get a really nice measurement of the hottest ambient temperature, which is what we're looking for in the bucket. So with the new update, adding this and adding the shield has made all of my temperature issues go away, and I'm getting better readings having it on the actual roll, and the dryer is working more efficiently. So this is how we load it up. So we take our radiation shield here to block some of the radiation heat. Put that in first, like that. Take your roll of filament that you want to dry. Put that in. Put your spike through. And so it looks something like that. You take your temperature gauge and you just clip it on top. Maybe put the filament over the top if you can. Like that. So it sits in there like that. And now your filament can dry, and you don't have to worry about the spool getting overheated. You get an accurate temperature. Works great. So with that, yeah, those are the updates. So guys, hope you enjoyed following this project. Like I said, I've written the instructions to assemble one of these. I just need to add the updates that I added, that I just described to you. Those are not in the current write-up, so I need to go change that out. So another day or two. We've got the flu has attacked my family, so it's going to be a little. It's going to take a little time to do that, but I will be posting that. Hopefully, in a if I can update the links in here, I'll update a link in YouTube when it's ready. It'll have parts lists. It'll have step-by-step instructions if you want to build it. So I hope you guys enjoyed the project, and that you try to build it yourself. We've gone through and shown that it is more energy efficient. It holds a specific temperature as opposed to just putting a light bulb in there and praying that it holds the right temperature, which is kind of important if you're trying to dry out nylon versus a PETG or a Ninja Flex. It's nice to have that temperature control as opposed to just being open loop. We've also shown in previous videos that you can soak nylon in water for days and bring it back to life using this dryer, or any dryer for that matter, given enough time. I hope you enjoy making this. If you have questions, I'd be glad to answer them. I'll put in the link in below for my, my Twitter account. Feel free to DM me anytime, and I'd be glad to answer your questions. Have a good day.